first step in determining an electron configuration is to label my periodic table, and I'm going to need to do that for everything, so I'll go ahead and I'll just do that now. So I have my 1s here, 2s, 3s, 4s, 5s, 6s, 7s, and I can label over starting at boron. I have 2p, 3p, 4p, 5p, 6p, 7p. And then for scandium, I have 3d, 4d, 5d, 6d. And then for cerium and thorium, I can do lanthanum and actinum, doesn't really matter, just as long as you remember that lanthanum is here and actinum is down here in the D block. Do 4f and then 5f. And let's do the electron configuration for down here. I'm going to do the electron configuration for hassium, HS. So HS 108. So I'm going to do this down here because I have a lot more room to work with. So it's HS 108. And now, just reading left to right. Oh, right, first, let me take helium and then put it over here. And S1, S2, D1, 2, 3, 4, 5, 6, 7, 8, 9, 10, P1, 2, 3, 4, 5, and 6, and then F1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Now I'm ready to read left to right, jump the gun. Okay, so hassium is down here, and so I'm going to start at the top, and I go 1s2, and I've reached the end of my first period, and then 2s2, 2p6 is the end of my second period, and I'll start writing down here. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So this is where the labeling comes in really handy. Remember, it's 3d, and then 4p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. Yep. So that's 5s2, 4d10, 5p6, 6s2. Then down here, draw my arrow, 4f14. Then it's 5d10 and 6p6. So I'll probably run out of room here. I have to go to the next line. So this is going to be 6s2, 4f14, 5d10, and then 6p6. And then finally, I go to 7s2, 5f14. Arrow didn't do. 5f14. And then 6d6, right? Because this is the d6. So if I go down here, this is a d6 configuration. Filling that in. That's 7s2, 5f14, 6d6, And that is the electron configuration for Hassium. What if I wanted to do an abbreviated electron configuration? Because this is a lot, right? It's a pretty long electron configuration. Sometimes it's inconvenient to do that. So what I'm going to do is I'm going to go back and I'm going to go up. Oops. I'll go up one period and all the way to the right. And I see that at the very end, I have radon, right? And so I can abbreviate all this stuff up here with the symbol Rn. So how do I know to abbreviate all this up here? I went back in my electron configuration. So I went from 66 back to 5F14, back to 7S2, back to 6P6, and I find that 6P6 is the very last filled P subshell. So it's completely filled. It has a P6 configuration. And so I can label anything with the P6 configuration with the atomic symbol for the corresponding noble gas. And so this becomes Rn. Seven S2, 5F14, 66. So Rn, 7S2, 5F14, 66. And that is a lot more condensed than all this stuff down here. On a test, you have a multiple choice test and you're trying to identify an abbreviated electron configuration for a given element. A few things you can do is, one, try and confirm that the answer choice has the correct abbreviation for the noble gas, or the abbreviation for the correct noble gas. So here, Hassium has radon as the last, or as its reference noble gas, right? It has an electron configuration that is filled up to the electron configuration of radon. And so Rn is the correct symbol for the abbreviation. Oftentimes on multiple choice tests, you might have an answer choice that has the incorrect noble gas for the abbreviated electron configuration. It'll often be in the same period, or they will go one period up to say xenon. And if you see something like Xe or Og, you know that that's going to be the incorrect answer choice. Another way to identify the correct answer choice is when you know that Hassium has we label our periodic table, so we know that this is going to be a 6d6 terminal subshell configuration. Oftentimes, the terminal subshell configuration will be incorrect in the incorrect answer choices. So if you see something like a 6d5 or like a 6p or just a 5d or something like that, then you know it's going to be incorrect and you can immediately eliminate those answer choices. Finally, incorrect answer choices will have the subshells in the incorrect order. So one thing that people do, I'm going to work over here at the top. One common misconception is that the subshells fill in order. So instead of going like, here you notice it's like 6s2, 4f14, 5d10. You might see something like 6s2, 6p6, and then 6d6 or something like that. And that'd be there to mislead you. So you know that this is 6d over here. And so people might think like, oh yeah, 6d, 6p, and 6 or 6s, 6p, and then 6d fill in order from sp to d, right? And that's not correct. They fill in order of increasing energy. And recall from another video that that is the Aufbau principle. That subshells fill in order of increasing energy, and the subshells are not necessarily ordered in a distinctly logical pattern. Right? They can be staggered like this. So instead of going from 4s directly to 4p, we have this intervening 3D. Likewise, we don't just go from 3s, 3p to 3d. We have the intervening 4s.